to a very high degree, fluid dynamics long before we knew that fluids were made of atoms.
Right.
And I don't know how much the public knows that atoms are, though the idea is old, evidence that atoms are real is relatively recent. And even in as recently as the year 1900, it was still kind of not sure. Right. And it wasn't really until Einstein and Brownian motion in 1905 where there was really good evidence that atoms were real things. Yet we had full understanding of fluid dynamics in any way that mattered for us.
But we also now can derive fluid dynamics from the atomic description in certain cases. Not all of fluid dynamics, but some of the properties of condensed matter physics we can derive.
Okay, I'm glad to hear that. So we're still talking about reducible things.
They're two separate things, though. We mustn't conflate. On one hand, I think, in principle, one can derive all of these higher level things. I think ultimately even consciousness, like David Chalmers is working on, from starting out with the quarks and stuff. But in practice, on the other hand, whether we humans are smart enough to figure it out, that's a whole different story. And I think I'm guessing that's what you were getting at there. You weren't saying that there's some mysterious epistemological gap that we can't.
Oh, no, that's not what I meant.
But that we might not be able to understand.
We haven't yet have the resources and probably enough tools and understanding to fill that gap, but the fundamental equations are there. It's just a matter of when we actually get there. So
I'm curious. This brings me to a point that we did not discuss earlier in the notes that we shared. When I think of you can know everything you can about cell biology, about how life works, and it's not obvious to me that by just studying a single life form, that you can derive evolution by natural selection, that's an emergent phenomenon given the system. So if it's emergent, then no one actually programmed it in to do that. That's just something that resulted.
Right, so the way I would describe it is I'd say that the fundamental, whatever's fundamentally there, that substrate is essential to whatever happened, but it's not necessarily essential to your description of what happened. And so the laws are following from this, but it's not giving an explanation. So I can note that there's atoms, but it doesn't help me predict what will happen when I throw a ball. I mean, in principle, I could probably figure it out based on that, put it all together, but it won't help me. It's so inefficient. So it's much better to have a description of a solid ball, even though it's made of atoms, which are actually mostly empty space. So that solid ball description leaves all of that out, and it works just fine. It tells me exactly where the ball will land.
David, you and your consciousness cronies, is it generally recognized that consciousness is an emergent?
To make ourselves feel comfortable with things we don't really understand. We say, it's emergent. There's different kinds of emergence. There's a gap with, say, complex systems. Again and again. Maybe it'll turn out evolution arises. Really cool, and then that ought to be explainable in principle. Now, for consciousness, people sometimes say consciousness is emergent, but there's a gap there of a kind that we haven't even begun to close in the gap of consciousness. People can tell stories about life. People can tell stories about evolution. No one's even begun to tell a story that enables you to predict the existence of consciousness from any amount of underlying physical dynamics. It explains the behavior, it explains how we walk, how we talk, but why that should actually feel like something from the first-person point of view, that is emergent in a much stronger sense. I'd say that's strongly emergent in the sense of it might require new principles to explain.
Max, is there any role of chaos theory in this? Because we know that in principle and in practice, there's some systems that are so complex that you cannot accurately predict its future behavior. Now, is that true even if you had an infinitely powerful computer?
No matter how powerful a computer we build on Earth, we can certainly could not have predicted that the Red Sox were going to win the World Series.